spent countless summer nights lying on my roof, staring up at the blanket of stars and wondering about my place in this seemingly endless universe. It sparked something in me. I wanted to answer questions that lied beyond our world, such as, where did we come from? What are we made of? How did we get here? It's easy to feel overwhelmed when you look up at the stars, but within the fabric of the night sky lies a question that's both cosmic and intimate, a question and a story that connects us all in a profound way. That story is of our cosmic origins, and it's one I'm helping to write with the next space telescope called UVEX. UVEX is a $300 million NASA space telescope set to launch in 2030 that will observe the invisible ultraviolet rays like the ones that our atmosphere absorbs from the sun. I'm going to lead one of the science projects with UVEX where we study different individual elements such as nitrogen, oxygen, iron, and carbon that make up all of the building blocks of life and everything you know and love, such as the air we breathe, the water and margaritas we drink, and the cells that sustain our lives. The early universe was void of these elements, but the first stars fused hydrogen and helium together to form heavier elements. And when these stars exploded, they scattered these newly synthesized elements throughout the cosmos, coalesced again to form new stars and planets. And in this way, every successive generation of stars makes the universe a little bit richer and a little bit more complex. This is what I research and what I will study with UVEX. By tracing the evolution of individual elements, we can uncover the narrative of how galaxies build up over time, how Earth and other planets formed, and how life itself came to exist. With UVEX, I'm going to trace this story backwards to try to find the origin of these elements and understand how we literally all became made of stardust. Yeah. Now, we have a pretty good understanding on how most elements were created, like oxygen and iron, but carbon is still a bit of a mystery, despite how numerous it is. And this is because the way we look for carbon is by these bright emission lines that are in the ultraviolet. But our atmosphere blocks ultraviolet rays, so the only way to study them is to put telescopes into space. This is the power of UVEX's ultraviolet vision. It gives us a different view of the universe than other wavelength regimes do. This is a picture in the optical, what we can see with our eyes, of our nearest spiral galaxy neighbor, Andromeda, or M31. You can see a disk, it's got spiral arms, dust, gas, stars. But when we look at this image in the ultraviolet, we reveal a different picture. We can see higher energies than we can see in the optical, and we get a different perspective. It's really, really powerful. But before UVEX was even a dream, I started my astronomy career with the Hubble Space Telescope. Launched in 1990, Hubble is now 34 years old, but it's still got its groove. Its cutting-edge capabilities allow us to still do world-class science today. Now, some of you astronomy aficionados may be saying, what about JWST? JWST is the undisputed champion of the infrared realm, but Hubble still dominates in the ultraviolet and the optical. It is humanity's greatest space-based observatory. Not only has it transformed our view of the universe, but images like this have captivated us and inspired our imaginations for decades. But Hubble's getting old. Some components are starting to fail. It's soon going to retire, and it will leave us completely blind in the ultraviolet. Fortunately, UVEX will be on the scene in just a few years, and it's going to transform our view of the universe in 3 profound ways. First, we're going to perform this really deep synoptic all-sky imaging survey that will first observe the entire sky in the ultraviolet for the first time, none of those holes, and it'll be 100 times deeper than previous surveys. Second, we're going to observe the dynamic universe, taking repeated pictures of the changing ultraviolet sky on cadences from 12 hours to 6 months that will allow us to discover transient objects like supernova explosions. And finally, we will observe the lowest mass chemically pristine galaxies. Now, these things are the most common in our universe, and they form the backbone of this cosmic web structure of our universe, but they're one of the least explored galaxy frontiers. But with UVEX's imaging survey, we're going to discover 15 to 200 billion galaxies nearby to us in our own backyard. Of less than 1% are known today. All right, now it's time you grab your squares. I'm going to study these very low mass galaxies with spectroscopy on UVEX. Spectra are where we split up light into different colors, just like a prism does. So to give you a demonstration of that, We first can look at a white light, so you all want to look over here, and you should see some sort of continuous color bar somewhere, a full rainbow, because all the colors of light are within this white light. But if we look at the light from a single element, we see something different. So if you now look and gaze at this spectral tube, this is hydrogen, and hopefully you see bright, distinct lines of purple, blue, and red. It should look something like this. Those are unique colors to hydrogen. So if we look at a different element, such as helium, you should now see a different set of colors. In particular, you should see a yellow line, for instance, that doesn't exist in hydrogen. Each one of these elements has their own unique set of lines that we call its spectral fingerprint, and it's the way we can observe light from distant galaxies and tell what elements are in it. UVEX is going to observe those special lines of carbon. Now, elements like carbon and oxygen are produced by smashing helium particles together in stars through fusion. If we smash 3 helium particles together, we get out a carbon atom. So given a certain amount of helium in a star, we expect a constant relative amount of carbon and oxygen to come out. We know what it'll be. But when we observed massive galaxies with Hubble, we saw a different trend. It seems now carbon is increasing with chemical enrichment of galaxies. Now, we have a couple of different theories of what could be producing this carbon trend, but we need observations of these lowest mass galaxies to tell them apart. This is where UVEX has the ultimate discovery space. We're going to be able to observe these very low mass galaxies that we discover for the first time and distinguish carbon's origin story. So our quest to map the stars and decode the chemistry of the cosmos will soon be shaped by UVEX, but we've already learned a lot from Hubble. I hope you find it a humbling and beautiful story that you have the universe within you, that we're literally all made of star stuff. So when you leave here tonight and you look up at the night sky, remember that your story is forever intertwined with the complex chemical history of the universe. With UVEX on the horizon and this profound connection to the universe in each of you, I don't feel so small anymore. Thank you.